Hello, I'm Matthew Benson, and welcome to CppAfrica and Matthew Benson Presents Fun with Iterators, Loops, Containers, and Algorithms. What follows is a recording of a Meetup session by the CppAfrica Discord group, where we got to discuss iterators, loops, containers, streams, and algorithms during our monthly meetup in the month of July. Welcome. I said won't have an interactive session. This time round, it's not really about slides. I don't have slides prepared, but the idea was to try and group solve the problem. And this is usually something I've been playing around with here and there. And I found that there are many ways to solve this problem that explore different parts of the C++ language. So that's the idea I had for us to do today. And I don't know if you're not familiar with the advent of code. Is everybody familiar with advent of code?
Maybe not.
Maybe not, sir. Okay. So advent of code is usually like it's a yearly competition that people do. I mean, there's a site called adventcode.com where from the 1st of December to about the 25th of December, there is a challenge, a coding challenge that has been set up, and people kind of like compete every day. A challenge is released, and people take the time to do whatever exercises are there in maybe whatever language they feel like doing. So there are people who participate just for the sake of coming up with the fastest solution. Others use it to explore maybe a new language and use it as a practice ground. So generally, it's usually like Christmas themed, and there's all manner of stories and scenarios they come up with. But at the end of the day, usually you're given there's a file with some input. It's a textual file. So what I have done is that I've taken the data from that file and I've put it into this string here. But generally a lot of the time people kind of like create generic solutions where they download the file, or your application downloads the file, or you download the file to the file next to your application, then you read in the data one by one by one. So one of the major reasons why I have set up this project on Godbolt, this is a CMake lists based project. It's a way to set up a project. I don't know if you're familiar with it.
Yeah, I guess we are.
Okay. So basically, you just do, there's you create a file tree, and you add a few files that now makes it work kind of like a regular solution. So here I only have two files. Basically the input1.hpp, which is where the input file comes from. And now this is basically the framework I've set up now to kind of like focus on the task at hand. The major reason I've started with a string stream is to simulate the idea of using a stream like std_cin for input. But in this particular case, a string stream is basically it's like standard cin, but that looks at a piece of memory, so to speak. So this is how you create it, like on line 7. Then, okay, the highest. This is the figure. The answer that we're looking for. So if we look at the input, the idea, I've kind of like jumped a step because generally you have to figure out from some long story how the task is supposed to be done. So I've kind of like short circuited that. Just start with the data so that we can focus on the task at hand and not be bothered with these other details. So generally, the idea is this information will come in as a stream, character by character by character. And the point is that the data is in sections. So you're supposed to get the sum of a section and, kind of like either store it up somewhere or keep a record of it and check for the section with the highest sum. I hope that's clear. You get me thus far?
Yeah, we are following.
Okay, fine.
Is
So,
everybody on the same page?
there? Yeah, that's kind of like now that those are the things that now you're supposed to figure out. But I mean, so this is a raw string literal. So everything from this is exactly how the file comes when you get it. From the site, and then usually everybody has like their own unique. There's a way they've randomized it, so everybody has their own unique solution. This happened to be mine. So the core thing is that now once we're starting with a stream, assuming that we've read in a file, could have nef stream with whatever file is on disk. The most important point is that we're starting with a stream, and the reason I wanted to start with the stream is this is one of the, shall I say, oldest, kind of like foundational data structures that have been in C++ for quite a while. And it's one of the ways that we use to, it's used for input and output. So we're assuming in this particular case that the data is being input and we need to decode it and, kind of like categorize it and break it down. So does anybody have an idea? You can shout out like what you think we can type here to solve the problem. Then we kind of like, I'll type it out for us. Then we can kind of like take it up from there.
So this just a short question. So we will need to save the sums of each section somewhere, right? And then we compare to see the section with the highest sum. Basically,
Yes.
that, right?
Yes.
Okay. Oh, my screen is off. I can't see the screen.
It's gone off. Okay. Okay. I guess I need to restart the sharing. Okay.
Okay, so what I would do first, maybe that's the worst solution someone can ever give. But but since we are taking an input from a stream which we do not know obviously the each section is separated by a white line, right?
Yeah.
By a next line, sorry. So maybe I would dynamically allocate. Maybe it could be changed later, but I would dynamically allocate uh um okay, relax, let me think again and come back. And then
Okay. So let me kind of like jump into. Yeah, sure, go ahead.
The audio is being recorded. Okay, so I didn't. Let me just explain because I didn't really get the question. So we're to
Okay.
sum everything in sections, in every section, and then
Yeah.
so we're like, so the output would be the sum of every section. So it should just be an array of all the sums of the sections.
Yes. Then we get the highest one.
Okay, so I think we can. Okay, let me start. I think we shouldn't. The first stage is to we can have like an output vector, right?
Yeah.
Okay.
Okay.
Then we just keep reading each line. So from what I can see, the section is the a section is differentiated by an extra new line. So we can use some sort of like a get line function, and we loop through that until the next get line is empty. Then we have a running sum. We take that, push back into a vector, then we go to the next. We like start the running sum again. So until we're done reading the input.
So basically, it's like, okay, we have a vector where we're going to put in the output, which is of type. I'm being very verbose here because we have to. Okay, these integer types can be very tricky.
By the way,
so what do you think we should put here?
Is off again.
The screen has gone off.
Yeah.
Why is it doing that? Okay, let me see. I'll Explorer share. Has it come?
Yes, it has.
Okay, fine. So we have. This is where we'll be storing of what, sums or numbers, because things that now you're supposed to figure out. One of the first things is that you see the input. This is a raw string literal. It's a string. This is just a string of characters. So we have to. Does anybody have an idea? Convert them. There has to be some kind of conversion. Then I think okay, let me put this here. So we have to read in the characters, somehow. Then you mentioned storing the set sums or the numbers. Am I right, Uzo?
Yes, the sums of the numbers.
Sums of the numbers, okay.
So were we given any? Were we told how the shape of the data, or what the data is composed of?
Usually, you're just given like it's just a file with just like in this format.
So
yeah,
we're not even sure.
Okay, it's not from a. It's hypothetically from a file, but I've specifically put it in a raw string literal, which just it's short circuiting. So it's kind of like here, it's a string stream, not a file stream, but it behaves exactly the same.
Okay, so when we take in a line, we have to convert that line, the content of the line, to a number. Well, that can true.
Yep.
Okay. But anyways, those are implementation details.
Yep, it's actually quite important. But yeah, So the major reason why I started with streams is streams. I mean, if you look at the headers, okay, there's IO stream, which gives us std scene. Then what we're using here is std string stream. Then like if we had a file, then we'd be looking at std f stream or input file stream, depending. So the major reason why I started with streams is streams are one of the few APIs in the C++ library that's actually object-oriented. I think maybe when it was developed, it's a very it's very heavy on object orientation. So all of these strings, in fact, there's usually an I string stream, meaning just for input. So they all have the same API, basically. You know, with I don't know if you know these are things from way back when, where it's like how to read in an integer using from std_c. And does anybody know, like off the top of the head, how that would work?
How to read what? An integer from a string?
For example, yes, from the standard input.
Use
std scene.
or what? Like from the standard input, so use scanf.
Scanf is very C.
No, like okay, with C++ from the standard use. So use C in use C in std_c in, and then with the stream insertion operator.
Yep.
Okay. That's what
I know we're very familiar with the cout.
Yep. And then with the stream insertion operator.
We're very familiar with that.
Yep.
But how to now get information in?
Yeah, so maybe most of the time you just maybe a small cout that's okay, receiving this variable when you create the variable, and then you pass the variable by referring, I think, the address of it to cin, right? Like this. So cin, and then the variable that you want to store whatever that you are taking in, right after the prompt. That should work.
Okay, so like that, right? That's like that should be
exactly.
That should be how it works, eh?
Yeah, that should work. Yep.
Okay, fine. So fine. That's okay. So I just wanted to just establish that there's this I'll call it a common API for input and output that uses the same semantics, so to speak. So if, for example, I was talking about input here. So let me kind of like annotate this with now the output versions. I should be able to, for example, if we are outputting hello world, I should be able to do the same thing with, say, some output file stream of some kind. Hello world. So the point I'm trying to just bring out is it's the common API is like how, somebody designs like a basic way of approaching problem, and how the same pattern is repeated for things, kind of like within the same class.
Okay.
So the thing about streams. Okay, or rather, let me start with something else. So let's get into the loop. Let's get into now actually just processing the data based on what you just said. So
Okay.
before we get to all of this, the while something. So let's say we have. Let's start with the character. RC. I don't usually like. So input stream. Now the API for stream, I'll just kind of like. There's a method called end of file.
End of file.
Yeah. Let's do. Okay, that should work. So let's see if it's doing what we want it to do. Should be outputting here. Or have I made a mistake somewhere?
Is it to the compiler error?
No, there's no compiler error. I've seen where the problem was. I'm using vmode, so I don't think it has compiled it. So program returns 0. Okay. So it's compiled. I'm trying to figure out why it's not outputting.
But what are you trying to get? You're trying to just print the values from the file, right?
Yeah, for now. There's something I'm trying to get at in terms of the API, like dealing with the API.
Okay. I was suggesting check compiler options. That get option. There's a get icon. Yes, beside a.
Okay.
Yeah, execute the code.
So execute the code. So it's meant to execute. Okay. I'm surprised.
All right. Okay. So anyway, the core point is that input stream.end of file. Let me try something else. See if that works. Okay. There is output, just that it has been truncated. Let me see if I remove the new line, what happens. So,
Program return 153.
Pardon? So anyway, the point I was making is that see
maybe cut it off after like a few iterations so that it doesn't truncate. Maybe 10.
Okay.
Because the file is massive.
The counter. That should be good.
Could it also be because C is empty and it will be printing an empty thing all the time? Because you have not put anything into
the C. You're right. You're right.
We're printing garbage.
That is actually the reason. So the point is we've not put anything into C. So let's put something into C. That's actually the... So put something into C.
Exactly.
Yeah, that's it. Thank you, Dennis. That was it. So the point is the stream because we specified that we want a character, it's processing just character by character. Yep. So say I change this to a string. And what do I need to do? I need to put a new line. Yeah. So that's
We have it.
it's something a bit more reasonable, because we are telling this the stream to look for. Let me take this out. To look for strings. So how does it know? How does it? Why is it behaving differently to the character?
Yeah, why is it behaving differently? Why is the string behaving differently from the character?
Yeah.
Yeah, because there's the I don't get your question. Like
Okay, I think
we are trying to
there's an
print.
overload. There's an OF stream overload for strings, I guess.
So if I do it this way,
Is it mapping them to ASCII or what is it doing?
basically, see for example, like this is actually even what I'd wanted to show initially.
Mm-hmm.
So when we are
Okay.
processing the stream, we're telling it read a character.
Okay.
First thing is like, what is the size of a character?
It's a single byte.
Yes. So it's able to reason and recognize that, fine, this is 2, 9, 3, 6, then 2, 1, 5, 4, and so on and so forth.
Mm-hmm.
So that's what happens when you use this particular API. But I think Uzo mentioned something about what is it? Get line.
Yep.
Yep. So let's try get line. Does anybody know like how get line works just from the top of their head? Do we have to go and look for it?
You have to pass the string that you want to use, like the string that you want to. What's the destination of what you want to get, and then you pass a reference to, I think, a pointer to the destination. I think. Let me verify for you. Let me see.
Okay.
Yes, exactly. So you pass the destination to it as the second parameter, and then you pass scene to it as the first parameter, which is the scene string.
Mm-hmm.
Yep.
Okay.
So that's the string, and then yep.
Do you notice a difference?
Okay, so this is using getLine, right?
Yep.
And this one printed as spaces.
Yep.
But the normal cout did not print the spaces, right?
Yep.
Okay, and this
So
is basically the string. Yeah.
So if we use this API, this input stream C.
Mm-hmm.
Did I misspelled typo? Okay, input stream. So no spaces basically. Yep. Does anybody know why? that is the case.
That's in the difference in the the spaces that's printing.
Mhm.
That's so as in a stream, if the get line function in C++ is trying to I'm coming there's when we use cout, it didn't print the spaces, right? And then the get line rather prints the spaces. Exactly. So that, as we are saying, the get line gets every single line. Yeah, but with the cout, it's trying to get byte addressable values that are found in the single stream.
Okay.
So because the CL uses the stream extraction operator, as I said, it tries to fetch byte addressable values from the stream.
Yep.
It tries to extract byte addressable values from the stream. But with the get line, the get line is able to distinguish between the new lines that are met. But maybe there could be like deeper reasons to it. Yeah.
Yeah. So basically, the in the API for streams, you see, remember, like the input stream could include stdc in. So, for example, when you tell stdc in, give me a number, and somebody starts typing, 4358, the way that it knows to stop the process of inputting the number is the moment it finds something that's not a number,
Exactly.
it stops and takes everything that you've typed in and puts it into that variable that you just stored it in. So there's a name for this kind of behavior. If you look at Compiler Explorer, it's called, there's formatted versus unformatted. So this input stream here is formatted because it's kind of like expecting to be used basically like kind of like from the command line. But getLine doesn't ignore the white space. That's why it captures where there are spaces. It takes all of the characters and just basically outputs, like for example, like here in between this 3526 and 1673, it is storing an empty string, which is just two new lines, basically. Like in the input file, just the character stream. After every line, there's a new line character, a new line, a new line, a new line. So when it gets here, it treats it like an empty string. So that's now unformatted. So that's something that we can use to kind of like know, okay, this is the end of a section. So basically, okay, the input stream way of reading in the input is not helpful to us because in this particular problem, we need the new line characters.
Okay.
Yep. So basically, it's like, so from line 17, we're saying, while we are not at the end of the stream, get line, put it in C, and then, kind of like print it. So that's mostly how, streams work. Streams have been, kind of like a very big foundational thing. In fact, so basically, okay, now we've covered reading in the characters. Yep. So that's kind of like step one. But the characters, they're strings, and okay, if all we wanted, for example, to do was to order the strings, then we can kind of like have string 1 and less than string 2 and check kind of like which is less than the other just based on the characters. But that's not what is needed in this problem. In this problem, we need to know, like, we need to get the string as a number. Yep.
So
and then,
okay.
Yep. So each section we have a string of numbers. I mean, or rather, these are strings now. Now we have
Okay.
1, 5, 4, 15. These are now strings. Do you have an idea of how to get numbers from it?
Yep. Using std str. I call it struto, but either stour and stoul. Yep. So I'm assigned, or if you want to use a normal. But since we don't know the values that are coming, it will be maybe more safer to use an integer value that can code maybe bigger ones to no overflow. So maybe we can still be fine with std str toul
or
or
STOU.
maybe stoi is fine.
Yeah, I think, okay, fine. We can, if we look at the input, we can see that first of all, there's no negative numbers. So I think it may make sense to use an unsigned. Okay, so unsigned basically is the ideal.
No, but I think it's better if you use both signed and signed like integer because we are blind to the data. So
Okay,
what if someone is said?
in this
Yeah,
particular case,
yeah.
in this particular case, we know for a fact this is the data. So we know there is no negative. Okay, if we are reading, kind of like from the yonder, then of course we'd go with integers. But okay, in this particular case, you can see they just kind of like just the longest, I think, are like maybe 5, 6 digits. So it's something manageable. So I'll say
Let's just go with integer. It's fine. Let's go with integer. It's fine.
we can also go with integer, but I prefer going with unsigned when possible. But okay, fine. Let's do integer. So so this is for the store of numbers. But so as we're going section by section, we could possibly have like a vector somewhere. A vector of let's put this up here. Okay, so a vector of output and maybe another vector of int for the numbers. Yeah.
Okay.
So okay, so this is where we'll store the numbers that we've passed. So you said, okay, after getting the line, so we can check, okay, if say, so let's give this string a better name. Okay, so we have the number string, so to speak. Or rather, let me rename that again. Okay, so get line into a number, into a string. Now we have a string. So if number string is not empty,
okay,
we'll go with that. Okay, so if number string is not empty, then we can do numbers dot emplace.
Back.
The value STOIA number string.
Okay.
Yep. And possibly let's print it out. It should look the same. But this time we know we not number string, but numbers dot back. So kind of like what we just put in. Let's see if that works. And place back. What is the error it's giving? Oh, vector header issue. Okay. Okay. So we have basically numbers. Then I think so. If okay, I think we could possibly do it like this. Okay, so when we get to a place where the number string is empty, then we get the sum. I mean, we can kind of like, now you see the point is now we have found a way to put them into sections, and we also have the vector of numbers. So any idea what to do next? Okay.
I'm just
Okay,
curious. Okay.
Yes, Dennis.
I'm just curious. If we skip the spaces, how would we know where to terminate the sum for each section,
Right.
for each block?
Right.
So basically, yeah, that's kind of like what I'm trying to get at. You see, here we have checked if it's not empty. So basically, there should be an else here, where now we process that the alternative. Let's say we say okay, space. Let's see. That does. Yep. So we're getting a space here, which corresponds to 3526. So basically, we have the different sections and we have the numbers. So Uzo, you mentioned a running sum. Yep. So I believe, okay. So when we get to the end of a section, or rather in between a section, we should be summing. So let's have like a sum here. Yep. So we do sum. Okay. So let's say we do. I'm forgetting how to. I'll just use new lines instead of the sum. Okay, where am I going wrong? New line. Okay, fine. New line is a character. Okay, so let's see what that does. turn that into a string. Okay, so we seem to be getting somewhere. So that's where we're at now. Yep. How do we fix it?
Sum is
Okay.
the sum counter. When
Okay.
it yep, into the sum counter.
Okay. So I think that's more reasonable, yeah?
Mm-hmm.
So we have the sums of the sections, right? So
Yep, maybe.
what are we remaining to do? So we've already done this. The exercise was to get the highest sum.
Yeah. So I think that if we are about to reset the sum, then maybe we'd also need to I'm coming, hold on, you like the container, I'm not seeing it, but the container containing the sum should come in.
Okay, I have an idea.
Yep.
Okay.
I'm not seeing
What about maybe keeping track of the max, and then anytime we reset, we do a comparison with the current max, and then update the max.
Yep. Highest. Okay. So highest, I think we had added a variable for highest. I think, yeah. So we have the highest. Huh? So basically we compare, like if the current sum is greater than the highest, then we store, right? That should do it. Where have I gone wrong?
What does the numbers vector contain? Contains all the numbers.
Yeah, I've actually been even. Oh, okay. Yeah, that's where I went.
Yeah. And the output, okay.
Okay, so let's see. Let's comment out this stdc out so that we can just focus on the result.
But I was thinking, maybe, I don't know, but maybe instead of keeping track of all the numbers in a vector, we actually keep track of just the sums in a vector.
That's a, yeah. So basically here, instead of doing m place back, we just add basically to, okay, we store it in a variable, yeah, right? So number is stoi number string, right? Like that.
Mm-hmm.
Then we just add the number.
Maybe that could fine, yeah.
Okay. So I can confirm that that is the answer. Yeah, because I've done this a number of times. Yeah. So what we've just done, I mean, this is like, remember, I don't know if you recall in the conversation we're having with Connor about,
Yep.
kind of like the way we just know how to program. This is how, global variables and, storing things. Yeah. So the streams, streams are something that, people have been working with from such a long time. I mean, Emmanuel, you're talking about scanf, and which also works on streams, but that's just the C way.
Yeah. I've been writing C a lot lately, so
Yeah. So all of this, like one of the thing about this exercise is that first and foremost, okay, we used a string stream, kind of like to have the same semantics as assuming that we're reading from standard out. I mean, standard in and the like. And it's actually a very reasonable way to do it. And one of the major reasons is this this method, this st, basically string to integer. That's something that's relying on the string library, and as well as the stream library. But this is very, you see this, I think let me see, I can remove that. I don't even think, we didn't even use the output vector. We just used variables to keep a running score, and it's correct. But I'm trying to see how to describe it. Like, I'm trying to see how to bridge now from this world to the algorithms world. I mean, it's said to be a best practice to go, I mean, to work with algorithms.
Okay.
Especially because of places like here. I mean, at the top of this while loop, you see these conditions. This just happened to be, okay, fine. I know that input stream happens to have a Boolean, conversion to kind of like to tell us about the end of the stream. But streams are very, or rather, streams hide a lot of the ugliness, not the ugliness, but the fundamentals of what's actually going on within themselves. It's a stream that keeps a counter of which character we are actually on. And yeah, okay, I don't know. You tell me, are you happy? Are you happy? Okay, we've solved the problem. So if we're competing, we'd have, I mean, we'd be off to the races. But it's, how do you see a need to, kind of like upgrade from here? Like in your mind?
I'm just curious.
Yes.
If we worked with the raw input as an input file without using a string stream,
Yep.
wouldn't that be a bit more straightforward?
No, it would be virtually the same. Because if, for example, like if the string stream is just kind of like reading from memory as opposed to reading from the point I was making earlier is that the API is exactly the same. So if, for example, I did std, file stream or input file stream to be input stream, then I know, like, there's a name of the file, .txt, and there's some conditions here. Everything from line 12 down is exactly the same. It would be the same even if we wrote our program that, kind of like enter. I don't even remember how to do this, where you do like a cout, with instructions of enter numbers here, and std cin until, kind of like, you keep on looping until you're satisfied. So you'd put in a number, press enter, put in a number, press enter, put in a number, press enter. And that would be the same as, just manually typing. That's how it would be if you use cin. Then when you get to, kind of like the end of the section, you press enter twice, then it stops. Then now you start again, like enter the next section. So that's the point I was making, is that the streams, it is an object-oriented, it uses an object-oriented style. That there's actually a base class. All of these classes, the string stream, std cin, and the like, they all inherit from something that goes like std, I think, basic input. You can look it up in Compiler Explorer, but that's the way the stream library is structured. So the the title of this session was supposed to be about iterators. What exactly are iterators, and kind of like where we find them, and then like I think let me see if I can switch over to
But can I can I say something?
Yeah, sure.
Secondly, Dennis was concerned about we using file stream, right? The if stream rather than the string stream.
Yep.
And you were saying it's basically the same, right? If we use the string stream and the if stream, right?
Yep. Okay, let me see.
Okay. But Dennis, do you have any like technical reason behind your concern? Like why you think we should use if stream and not string stream?
I was just curious if there's a way of using the file as it is.
Yeah, I think that if we are using a large file, if you are using a small file, the difference might not be much. But if you are using a large file, it's best to use a file stream because we would be reading the data directly from the file if you use a file stream.
Yep.
But if you use a string stream, we would have to map into memory. It would have to, sorry, not map into memory, but load the whole file into memory to, basically the same, to give it a memory address so that the string can point to it and then read it one by one. So maybe his concern might be valid. I don't know, because if the file is large and then we are getting from a string stream, we'd have to load the whole file first into memory before reading it from the memory. But if you're using just a file stream, maybe that's straightforward. I don't know. It's just my thoughts, but
yeah. So I, can you see the? Now we're on CPP reference. Can you see the table?
Mm-hmm.
Yeah. So I was saying that the streams library, it's how C++ envisioned input and output, especially at the beginning. I think this kind of something about like that came up in the 90s. Okay. So it's very object-oriented style. Okay. So you see, you have like a base with like this base actually has so many methods of the details of how you go from one character to the next, and it's kind of like a collection of like when you specify, for example, when you do std cin or file stream or string stream or just ios stream. I mean, the standard input and output. You have to specify the size of how that stream is reading characters. So, for example, if you do this kind of input, especially on Windows tends to be 16 bits per character. Yeah, this WKT is very, very popular in Windows because now that's how they were able to accommodate more than, the many languages that they intend to support. So CAR is basically foundational. That's now ASCII. And if you know the size, the maximum number of characters that can be stored in the ASCII, or rather with 8 bits per character, is 256. Okay. And ASCII, I think, goes up to 128. So what happens from 128 to 256? Now you get into a whole other world of, because it was limited, different languages will store different things in the 129 to 256. Okay. So it became a very big mess. So there was that push to kind of like widen the characters. So Windows at the time, that like in the 90s and they chose to do 16 bits per character. So if you find yourself working in the Windows API, if you find yourself having to deal with 16-bit wide characters, okay. And other but that was still not enough. So there's we've gone up to 32 bits. I don't think it's gone beyond that. But that the point is there's a lot of confusion about all of that. And a lot of the time what we use these days is UTF-8. And the thing with UTF-8 is that it's flexible. It varies. It has a way of calculating the boundary. So it can store anything from just 8 bits, the normal ASCII characters. So if you have like a normal ASCII character, it'll use 8 bits, but it has a way to grow. And that's why it's what's used on browsers, and they like to accommodate all the many languages and all the many characters, because it has a way of calculating at the boundaries. But I'll not go into that today. The point basically I was just trying to highlight is that the streams is very object oriented. But now this was supposed to be kind of like a way of highlighting iterators. These the iterators and the containers and the STL, the standard template library, handles this concept of a similar API and many kind of like child classes in a very different way. It's not based on inheritance, but it's based on a similar idea. Like you see, for example, the SDC in the called chevrons, I think, the left arrow and right arrow type of thing. That's a common API that's used in that particular case. So iterators, it's the same idea, but it uses the API of a pointer. And the API of a pointer, like for those who have kind of like dealt with like C arrays and the like, is that there is the element of dereferencing and incrementing or decrementing, based on the size of whatever data you're working with. Okay. And yeah, so that's basically like the API. But there are many ways of that API being used. So there are kind of like a few categories of iterators, and yeah, with increasing, kind of like with the most basic, and now they go increasing in complexity. But before I get to that, one of the major things I really wanted to point out is, let me ask this question. Can you say where iterators come from? Like where in the library, like if I needed an iterator, where would I look for it?
Asking which library would you import?
Something like that. Like where are they defined, so to speak? Like where do you find them?
Okay, algorithms.
Algorithms. Okay. Let's go into the algorithms library and let's have a look. Okay.
Wait, did you say iterators or the algorithm? Sorry, I think iterators may have its own header.
Yes, it does. It does have its own header, but that's kind of like not where they are. Like you see, there's a library of iterators, and we can see that there are categories. But okay, where do you, like if I need an iterator, where are they found? Where are they defined? Where are they? Where does the meat and bones of the? Where are they stored, basically?
Okay, I'll go with algorithms. I think both. Okay. I think algorithms maybe pulls iterator or something.
Okay.
I'm just curious.
Yep.
I think if a class is implementing some methods like begin, end, then the language runtime has its way of knowing how to use that as an iterator if it defines certain APIs.
Okay, so like you mentioned something like begin, right? So where do we find the begin method?
You have to define it in the class. So if you're building, let's say, a string class, you need to define a method called begin.
Okay.
That that returns a pointer.
Okay.
I'm not sure, I'm just guessing, but I'm thinking it's an implementation. Like, should I say it's like it's like an abstract class
Yep.
that implements those methods, and then
Okay.
that qualifies it as an iterator by definition if it meets certain criteria like begin, end, C begin, C end, etc.
Okay. You're heading in the right direction. You're kind of like getting where I'm trying to point at. So if we go and look at a string, so this is the basic string class defined in header string, right? So it's a template, so it has a character type. I don't know if you recall, just before when we're looking at the streams, if we look at, for example, like basic input stream, this is one of the parent classes. One of the things you notice a character type is one of the foundational things. I mean, we need to know how big the character is that we are looking at. So the thing is, so back to string. So you mentioned something about begin, right? So fine, string. There's something like iterators. There's a section called iterators. So begin returns an iterator to the beginning, right? End returns an iterator to the end. Then our begin returns a reverse iterator to the beginning, and our end a reverse iterator to the end. So basically, yes, there's something about like whatever class you're writing needs to define a begin, end, our begin, and the like. But notice here it says an iterator. It doesn't tell us anything about that. Let's look at the method itself, right? So it just says iterator begin, const iterator begin. So my question was, do you have an idea where we find this iterator?
As now you referring to the pointers that like the pointers directly or the libraries that we can import to use them, that we can include to use them.
I'm kind of like asking, well, if I wanted to find this iterator, where would I get it? Okay, as Dennis mentioned, say for example, like in a string, if you have a string and you do dot begin, so this is a method basically in the string class.
Okay.
I'm supposed to get an iterator.
Mm-hmm.
Yeah. So Dennis was onto something that fine in the string class, calling dot begin gives us an iterator. But where do we find this iterator? How do we get to know about it? You saw me mentioning here that there are 5 categories of iterators, and there are the many things that they can do and the like.
So like they are member pointers of the class of the objects that you created.
Okay. So
I don't know if I'm answering your question honestly.
okay. So let me ask what I'm trying to ask in a slightly different way, right?
Okay.
What kind of information can be stored in a class? In a user-defined type, what can we put in there?
Variables.
Yep.
Methods.
Yep.
I think can you hear me?
Yep, sure. Hi, Jennifer.
Okay, like copy constructor, move constructors, the iterators you mentioned too, obviously. Different types of iterators. Maybe you want the const iterators, the non-const one too. Depends.
Okay. So
You mean like the user-defined container classes, right?
No, just any class. In any kind of class. What kind of
Any
thing?
kind
So
of
just
any kind of class, yes. Copy constructor, move constructor. If you want them, if you don't want them, then explicitly delete them. Obviously.
Okay. So this
to make them
the
submit
reason why I'm
variables
going
and
into
methods.
all of this is because there's usually something that's it's very confusing. Okay, it's something that I mean even I just discovered it the other day. So we are looking at the kind of like the manual for classes. So a class is a user defined type. Then we say a class can have the following kinds of members. So data members, which is usually kind of like the information that is stored in the class, the ints, and which is, I'll call it kind of like an instance of something, right? Then there are the functions, which like Jennifer was saying, the constructors and all of those are just simply functions. But a very important thing that can be included in a class is another class. So it's nested types, basically. So it's something that you define within the body of the class declaration or definition. The point is, it's a type that you design. You can kind of like have types within types, right? So
Okay.
this particular thing is something that's not usually so obvious, especially when you're looking at the structure of classes, and in particular, the containers. So containers, they're generally like templates, but they're classes. They're class-based templates. And as part of that structure, now, like I mentioned, like the streams library is very inheritance based. It's like you can get a pointer to the base class and the like. But the way the containers were designed, like now in the STL, is that they all implement a similar pattern. For example, the dot begin. For example, array has a begin method, but it doesn't
Okay.
inherit from anything. But it's just following like this convention. So when the compiler is, kind of like going through like your code, and if it finds there's a place you've written dot begin, it'll check your class and say, does it have a begin method? If it does, then it just compiles, right? So begin returns something called an iterator, just the name iterator. And so the idea is that part of what is in the array class is member types. These are types that you actually now define as part of the interface of your class, and they need to have these names. So there needs to be something called value underscore type, size underscore type. This is like the API, the common API that's common in all the containers. So then now there's a type iterator that is defined as part of the array that now adheres to the basic, the different categories. It implements kind of like a certain set of functionality, but it has the same name iterator or const iterator. So the question basically I was asking is, where do you get the information of, where do you get iterators from? So where you get iterators from generally is from the containers. And the reason why that is the case is each container knows how to navigate itself. Like that's a place, it's the one that describes to the outside world, this is how you get my information. This is where the beginning is. So if I give you an iterator, and that iterator, if you do plus plus on that type that I give you, it'll know how to navigate the memory, the memory subsystem, so to speak. So we just looked at array, and array is very similar to the old style array. So the idea is that just like you do the pointer arithmetic, it uses the same API that this type, this iterator, this type that array has defined acts like a pointer, but the methods for adding, plus and everything have been overloaded to suit the different types. So array, of course, just behaves like a normal array. But if you look at something like a list, I hope you kind of like have an idea of how lists work.
Yep.
It's usually just like pointer to a pointer to a pointer to a pointer. So it's not contiguous, right? So the iterator that is defined in a list behaves differently. Yes, it has the same API. You see, you look at it the same way. You dereference it with a star. You add, you kind of like point to the next one, but it has a different definition. It's called, in this particular case, they say it behaves like a legacy bidirectional iterator. Yep. So these are now the requirements. This is now the contract of how each iterator works. So the bidirectional, just based, we'll get into the different categories, but generally bidirectional by the name is that it can go backwards or forwards, but not all iterators are like that, right? So so containers are one of the places where you find iterators, but there are methods to look at iterators, and I'll kind of like just jump to it for the sake of time. There's a std begin. Am I in the right place? Type operations. Just a moment. I clicked the wrong link. Iterators library, right? So in the standard library, there's actually there's some non-member function templates which provide like a standard way of looking for those iterators within the different types. Yeah. So these methods, now this is now not container.begin. This is now just std begin. And it's something that has been there since C++11. And as you can see, it's something that's defined by each of the, like in each of these headers, there is a definition of std begin that generally that corresponds to whatever type of container. So there's a container.begin, and then there's a std begin. And the reason why I wanted to get to that is if we look at now std begin itself, right? Like I said, you can see it's defined in all of these places where generally we want to be iterating over different types of things. So there are 4 different things or different overloads of std begin. The first one takes a container of some kind by reference. So you do std begin, say vector A, whatever vector, let's say a vector. And it does decal type, meaning it looks at the type of C dot, okay, basically it returns the type of the iterator that is returned at the begin method. I don't know if that makes sense.
It makes sense.
Yeah. So then there's the second overload looks at a constant container. So this should kind of like be like a const iterator. But the important one, the reason why I came all this way and I'm laboring this point is this third one. And can anybody tell me, I mean, if you look at this, can you tell me like what it means?
Okay, so it means that for any type with a any container or any type that has a t and a size n, that the begin is equivalent to a pointer of that type when you take in the when you basically index it as the result of indexing the container basically with a value of size C.
Okay. It's a good guess. This is very hard to read, but basically what this is an overload of the begin method that takes as its input a C-style array. So basically, it's a way of getting an iterator into an array, because, like you said, like we were saying, that all these other iterators come from the various classes. Yeah, but the what is it called? The C-style array doesn't have that provision. So this is an overload. This is a way of getting the beginning iterator of an array, right? So to illustrate this, let's now go back to the exercise. Let me see
I
how
have
to
a
get
question.
back.
Sorry.
Yep.
Okay.
Yep.
So this is extracting the beginning iterator of a C-style array, and there's like a way to make it compatible with the existing C-style arrays. But then, how does this return the first character, the first element? I think the first element of a C-style array is the address of the array itself, usually.
Yep. So that's, as you can see, the return type is a T-star.
Okay.
Right.
I'm just curious.
But then,
Yep.
why aren't we doing 0 or something? Like, I'm just asking from a template perspective, like from what this is doing perspective.
Okay, so basically what this is doing is that this second template parameter, as you can see, it's a non-type template parameter. So it's basically it's a number. So it's a way of determining the size of the array. See now this array n. So it kind of like takes the when you pass it an array, it's able to get the size from what you've passed in. So that's how it's able to kind of like guess the end.
Does it decay? Because typically when you pass an array into a function in the C style, the array decays into a pointer. So doesn't that disappear, the size, as you pass it as a pointer, as an array?
It's kind of like similar, but the point I'm trying to labor here is the word begin. STD begin. If you pass an array to STD begin, you get an iterator, which is actually just a pointer. So like earlier, you heard me saying that iterators take the interface of pointers, like the way we do in the C-style array. So in the case of a normal, like just the C-style array, if you need to get something that's like an iterator using begin, the begin method, that's what this overload is for. And then there's another one for the end. Right? So this is now the 4 overloads. It's just the same, but for end. So there's a reason why I've gone into all of that, because the purpose of iterators is they are the glue between the containers library and algorithms. So algorithms all have this kind of like API. It's a common API. If you look at any method, any what is it called? Any algorithm, so to speak. So for example, the find algorithm, see there's input iterator first, input iterator last, then some value, right? So the algorithms library is designed around iterators, like all the methods, like within like how these algorithms are implemented. They're implemented as though they're working with pointers, which are kind of like iterators. So, for example, this is how find is defined. This is the algorithm itself. Yeah, this is the possible implementation. So in the standard library, like deep in the library, it takes a begin and an end and a value, and it does, kind of like plus plus first. So this is like check the next one based on the for loop. So we don't initialize anything because first is already initialized. It comes from wherever it comes from. It could be a vector, it could be a string, it could be anything that defines that API, that it has something called an iterator that has this method, the plus plus, and has a comparison. Is a basic. This is now how all these algorithms are written. So there's the need to have the begin and end. It's a common API. You can write std begin and pass it any type of container, and it knows how to check what the iterator is. I don't know if I've lost you. Okay. Fine.
I was muted when talking. Okay.
Sorry.
So,
Yeah.
I was just asking, is it a way of making it such that you only have one, like a function like sort?
Yep.
That instead of having each container implement its own version,
yes,
you provide a common API, but
yes,
because the memory can be like the complexity of the implementation can be abstracted away, so you provide an iterator.
Yes.
That makes sense. So begin is begin irrespective of the container type. So
yes,
the algorithm library doesn't care about the implementation. It
yes,
just knows what to do.
yes,
But whoever is providing the begin method should implement what begin means on their side and what plus
yes,
plus is on their side, because plus
yes,
plus is different for different containers.
yes,
And that makes the library decoupled. So the libraries for algorithm and the ones for the implementation of the containers are separate. So you can have a simple, like a short library for algorithms, but it works on any container. And you can also bring your own custom versions that implement those APIs, and then it will just work because you are the one who's handling the complexity of whatever container you're making.
yes. That's basically the point. Yeah. So that's the point. So there's something I wanted to illustrate. Let me pop out of here. Let's go back to Compile Explorer. So in this, say for example, okay, we did this using the stream methodology, and the stream is one that handles, for example, the beginning and the end and all of that. Yeah. So let's kind of like start over. So we know, for example, the basic steps is reading the characters. This yeah, just all of these steps that we took. So let's start over. Let's just get rid of all of this. I saved the link of what we have done, and let's now imagine that. So if we look at the input, I designed it as a raw string literal, and I gave it a context per auto input data. So if we start again, let's say we so this time around we're not looking, we'll go character by character, but we're looking now at the memory itself, right? So see, let's try and use a range based for loop. So basically, we've gone back to the beginning. So we're supposed to be going character by character, all the way up to the end. And we're getting a compile time error. Let me even just do this a different way. Let's because basically input data, a string literal should be like an array. That's basically the point I'm trying to get at. Yeah? So let's do that begin. This is kind of like, I think, the C98 and say iterator is not equal to started end input data. And then we do plus plus. Then here we do that's basically what should be happening. Rather, now we're using iterators basically to try to traverse the collection. Can anybody tell me why this is not compiling? I think, okay, apart from the obvious blunder of not including.
Sorry, can you increase this stuff? Like, you can't see to the end of the for loop.
Exactly.
Okay, to the end of the for loop there. Okay, let me maximize it. Let me maximize it.
You might be missing maybe a bracket or something.
Yeah, okay. Let me see. Yes, I am. Yeah, you're right. So that should do it. Let me see whether it's compiling or running. Nope, we still have something going wrong. No, I've not finished. Include
the error message.
Include. Yeah, I've hidden it intentionally.
Oh, okay.
Yeah, so we've included the iterator header. We have we should be doing everything right. We've passed an array into started begin, but it's not happy.
Is iterator a reserved keyword on line 10 for your variable name?
No. This is the variable. No, it's not. It's not. That's not the problem. This one is a bit tricky, but yes, just give it some thought.
Please, we want to see the end of the loop.
I think it should be less than end, not equal to end. It should be less than.
It can be either, but yes, okay, let's say no. Actually, in this particular case, it's. I think I'm okay. Let's say less than.
I'm just
See what is the
wondering.
error?
Yep.
When you have the standard begin at the input data.
Yep.
In our case, it's a raw string.
Yes.
So this raw string, I don't think it implements the begin method that will then be captured by standard begin.
Yes, it's you're close, but see the reason why I used standard begin. So remember, like just a few minutes ago, I was showing you the difference between like container. Let's say we have a vector of 50 numbers, right? So let's duplicate this line. Let's duplicate this, but for the container. Still seem to be getting. Okay, not specified the type. Okay, vector of ints. So that works. And you can say, okay, there we have. Okay, let's do 5 so that it fits within the output. So it's a container with 5 elements. I've done std begin, and I've passed container to std begin, and it has worked. So, but this is not working for the string, for the raw string. So would you, does anyone have an idea why that would be the case?
The input data is a container, right?
It's this string here. It's basically something in memory. It's a piece of memory with these numbers that we processed earlier.
So maybe because that container does not contain a begin member, I see the pointer that begin is expecting to get. Maybe.
Okay. Anyway, so this one was a bit tricky. Actually, it caught me out a little. So I'll kind of like just give the answer where the issue. Yeah.
Is that okay? Yeah, give the answer. Sorry.
Yeah, I'll just go straight to the answer because it's a bit tricky. So the idea is that a raw string literal. Okay, let me even just change that card. Now you see it works. So we get character by character, 2936 space, and I think another space, and a new line, new line, new line. So basically the data is working now, right? So I don't know if you remember the std begin method. Let me just kind of like make a note of this. This method, there's this very funny looking method I was showing you when we're looking at the signatures for std begin. This third one, this one right here. This n, the thing about it is for raw string literal, it's like a null terminated string. So its size is not known at compile time, and therefore we're not able to kind of like determine its beginning and its end. So the reason why I went through all of that is to just highlight that the begin method works with either containers that have a .begin and return an iterator, or constant versions of the same, or arrays where we know the size in advance, right? So a raw string literal, though it's an array, it's like an array, but because we don't know the size of n at compile time, it's not possible to get an iterator into it. And the reason why I've gone into all of that is to highlight that this you see this style here of standard begin, standard end, and the like. This is what the range-based for loops rely on. Basically, a range-based for loop is basically the same as what we have right here. Let me just maximize. So it's basically syntactic sugar for this. So if I do S for to iterator from, say, input data. So now that I made it an array, this should work. Or rather, this is how the, let me see, oh, sorry, not supposed to be using that there. So basically the range-based for loops that came in 2011, they use std begin, std end. That's why they're able to work with various types of containers. That's, I mean, you usually see code like this, or something like, say, like if I use an initializer list, the reason why code like this works is because of the std begin method, because it's able to look and determine the size of this container, and then use that overload with a capital N, with all of that magic and the like. So that's one of the things I just wanted to highlight about what happens with iterators, right? So I've gone into a lot of, I don't know if there are any questions thus far.
Mine is to say, okay, I'm a bit confused in terms of the standard allocator. Does the iterator abstract something to do with that? I'm not very sure.
Allocator, you're talking about like what, like in vector, there's usually like an allocator method. I mean, you know, like a template parameter, and that's what you're asking about, right?
Yeah, I know it's not related to what you've just said, but I'm just I saw it on the CPP reference.
Okay.
So I was wondering if they are related, the iterators and the allocators, in terms of abstracting memory.
No, allocators deal with a totally separate thing. I mean, basically, generally, like vectors have like most containers have like a default allocator, which they use internally for getting memory. So I'm pretty sure. Okay, I hope we are all familiar with how, for example, like a vector works. Every time you call push back or in place back, when you keep on adding to it, because you see it's like we don't know how, it's something that can grow. So when it grows, it has to get more memory, and that's what it uses the allocator for. So I don't know if we are all kind of like on the same page there.
Yeah, it makes sense, because when the runtime notices that the vector is about to get full, or I'm not sure of the exact value it checks, but it then allocates a bigger chunk of contiguous memory. So
Yep.
So each container would implement its own type of allocator, or is it just for contiguous containers?
Okay, so what I'll say is an allocator it's a different API that deals with memory. It's basically like you see, iterators use the API of the pointer, which is the dereference operator and the incrementing operator and the comparison operator. Those are what the iterators use. Allocators have other methods like allocate and deallocate. So it's another different API, but that's something we can go into later. The idea is the containers have a default. Like when you don't specify, there's a default allocator that's specified somewhere in the in the library, and all that one does is that it calls new and deletes. So when you need like a new, or rather memory for integers, when it needs to expand, for example, this is a container of size 5. So when you've stored 5 elements and you add a 6th, the allocator will kind of like do new array of size. It usually doubles, so it gets like new memory that's 10 wide, and then copies everything into that new memory and releases the one that had the 5, so to speak. So it keeps on growing and growing and growing, but it needs to call new. Then when the vector is being destroyed, it will call delete on whatever pointer that it's storing internally. So that's basically like a different idea. The thing with iterators are the interface now to the algorithms. This now doesn't have anything to do with memory. And another very important reason, actually, it's good that you've brought that up. You see, when a vector, for example, allocates new memory and copies everything to the new location, so it allocates, let's say this is allocated memory. So inside the vector, there's a pointer to memory. So say when you do std begin on a vector, so this on in this particular instance, the iterator knows of the internal, kind of like it knows about this new pointer. So when it expands again, this is pseudocode. This is not a proper code. It's just so when it gets like a new memory location, it'll be pointing at a different place. So one of the things that even when you're working with algorithms, it's important to be very careful about the iterator that you've been given, because if anything changes in the container, you will be holding onto an iterator that's no longer valid. So this is part of the reason where each container handles all of that magic, but as the user of that API, you need to be very careful. And that comes up especially in the algorithms. There are some algorithms that they take begin and end iterators. So for example, say the find algorithm. It returns an iterator. So for example, if like in the example we've been working on, so this is actually a good point now let's kind of like let's start solving that problem that we had again. So the first problem we were trying to get at is finding the boundary between the sections. So say, let me see, input data. Yeah. Okay, so we go back to the ref. So now we're kind of like solving the problem but using iterators. Yeah. So the same ideas apply. So first thing is find the boundary. I think even the name of the task is self-explanatory. So how can we find the boundary? Any idea?
By boundary, is it boundary of the file?
Oh, sorry.
Or the section.
The section. Let me. Sorry about that. Find the section boundary.
Okay, we can, now that we're iterating by character, I think the next boundary would be a two consecutive new lines or something. Character.
Yes. So okay. So let's start by looking Let's go to the algorithm library and find a suitable way of finding for finding what you just described. So find is the first place we look. Let's look at the definition. I'll highlight it just to kind of like point out. I don't know if you see the problem. Yeah. So yeah, it's a good. It's actually a good observation, because you could check at the end of each. Basically, we're looking for the end of a line. Basically, at the end line character. So let's have a look. Say it says, okay, it returns an input iterator and takes a first, last, and a value. So the type, see this const ref, it uses a, I've forgotten what it's called, the type class template argument deduction to determine. So let's start there, right? So there's from the beginning to the end. Say let's look for the first new line character. So let's say so this is kind of like, this is how the algorithms now are used. So we have an iterator, which we've got from the big, I mean, like we specified at the top. Iterator. So that's the beginning. And that, okay, let me take a step back, right? So basically, we know we need to do std find, but we need a way to kind of like keep track of where we are. So let's lift out this iterator from here. Sorry, my Vim keys. I'll put it here. So before the for loop. And we can also store the end. Okay, so basically then we change the for loop just a little bit. And we can change that. Do you have an idea where I mean, are we following thus far? Let me just comment this out. But we know we need to find something. So now we're working with iterators. So I just want to kind of like make sure we're on the same page thus far.
And this only works when you have the array. I mean, when you change the implementation of the input HPP.
Yeah, that is basically what we're doing in input HPP, is that we are storing, because we know this data at compile time. Like I so we usually get, you're given like a problem. So just to get into iterators, we're putting it into a chunk of memory. So it's in an array, a character array, of which this now the compiler is able to tell that this is an array of character. It knows these are 8 bits, 8 bits, 8 bits. So it's able to count at compile time. But with the string literal, it wasn't able to count it will look for the zero byte when at runtime.
So even for the like for the vector,
Yep.
when it's resizing, so in a way it's able to keep track of the changing pointers, because the end and the begin, they change all the time whenever
Yes.
the vector or whatever underlying data structure is changing.
Yes.
Okay.
That's why each type defines its own iterator. Now that class that is defined by vector knows how to keep track of the internal things that are going on. But when you call vector.begin, it'll give you the current beginning and the current end. But you as the user need to know that if you add anything to the array, to the vector, like when we are dealing with algorithms, a lot of the time we are kind of like observing just based on the begin and the end. But we have to keep in mind that if there's a change to the vector, then if we had an iterator previously, then we have to get a new one, because what it's pointing to, it may be invalidated, so to speak.
Okay.
Okay. So thus far, I think based on the for loop, I think we are on the same page. But now there's something I was changing on line 12. Because once we do this, I want to find from where iterator is pointing to the end of the string. I want to find a new line. I don't know if that makes sense.
Yes, it does.
Okay. So I'm just trying out something to see if my assumption is right. So after doing find the new line character on line 16, I'm treating what I get back as like a pointer. So I'm minusing 1. I'm looking at the previous value. So I'm doing that just to kind of like test the theory. So we're getting 6, or rather 6, 4, 8, 0. So if you look at the input, you're getting a 6, 4, and 8, a 0. So I've kind of like tricked it. Just look to verify that we're finding the end of the line. But the point I'm trying to highlight is what we get back. What's a type of new line? What is a type of new line, basically?
It's an iterator.
Yep. Okay. So the core thing is that as now we're now going into the world of iterators, I'm just trying to illustrate that there are algorithms that will return you an iterator to the data. Now this is where we're talking what Dennis was asking about. If this was a vector and I get a new line from the find method, and then somebody comes here and adds kind of like to the container and pushes back something, this new line would not be valid. So it's our responsibility, kind of like as developers, to be very mindful that any iterator that you get from an algorithm, yes, it's an iterator pointing to somewhere within the container that we are looking for. And you can see in this particular case, we're looking for a new line. Then the point is, it's something that is our responsibility to be aware of as we're using algorithms and iterators, that you have to be very careful to make sure that you don't have an invalidated iterator. So in this particular case, we looked backwards. So on the basis of, I think Uzo mentioned something about new line. So I'll kind of like use a crude way of doing this. So let's say that's to next character. This is not like a good code. I'm just using to illustrate a pointer. So basically, we want a condition where new line and how do you put it? Okay, is equal to new line character and next. This is actually very, very bad. And does anybody have any idea why this is really, really bad?
Give it a go. This is brittle because this is just assuming that it's always two new line characters separating each section. And also these mathematics, this pointer mathematics and everything, it can cause issues.
It's you have an idea. I just realized it as I was doing. Generally, when we are looking at you see this dereference. This dereference on an iterator, we have to check if it is valid memory, because the issue is the end. So the way that we kind of like examine any iterator that we have gotten is that we generally have to check if new line is, let's say, end of string, and kind of like, we have to guard for the end. So I don't know if that makes sense. So the point is, we usually have to check that whatever iterator we have gotten is not equal to the end. That's kind of like how we know we've reached the end. So the way that we work with, example, like the find algorithm, is that we generally check if, okay, this particular case, the reason why I've done -1 is because of the fact that we're looking ahead for the new line. So it's just an attempt to make it safe, and I think I still have gotten it wrong. Next car. Oh, I've already dereferenced there. Okay, so that should work now. Okay. I'll not dereference there, but I will dereference here. This is actually very bad code. I'm just doing this to illustrate my point. because the new line is not printed. So I'm kind of like trying to get the next character. And I don't know if I'm doing it right. So, but anyway, I don't know if you're following what I'm doing here. I just want to make sure I'm not lost anyone. Okay, so the point is, the reason, you see all of this pluses and minuses and everything is showing us that, yes, we're kind of like looking for the right thing, but we've picked the wrong algorithm. And yeah, this is one of those places where it's like, it's not so clear. Find looks for a character, but we want to find like we want to find a range. Little range. Yes, let me see. What we want is a sequence of two contiguous things that are the same, and the algorithm for that is actually such. It's not very how do I put it? Clear. I mean, find sounds logical, but what we want is actually such, because such now looks for a range of characters. So the range of characters will now be the new line and the new line. And yeah, so basically we need to use such, and the interface for such is that we give it a first and a last, but also a first and a last of the range that we are looking for. So if we go back to where we were, say we create a string. So to wrap up, I've gone back to the stream version that we just developed, and I just wanted to take a look at this before going back to the version using only iterators. It's basically the same thing. We use a traditional for loop, which we start with the counter iterator, which is initialized with the value of standard that ranges begin. The ranges namespace is kind of like new overloads of the traditional algorithms that are designed to work on ranges. But we're not getting to ranges today, but that's something we plan to look at possibly next time. So we initialize the iterator, which we'll use for keeping track of where we are, and the end iterator, which should point to the end of the whole sequence. And then just like the traditional for loop, there's a semicolon, the second section being the comparison, checking to make sure that the counter iterator is not equal to the end iterator. And instead of iterator plus plus, in this particular case, we are advancing by 1. This particular method is one of the utilities for dealing with iterators. And the special thing about it is that it keeps track of the end iterator. So the reason why we're doing this is because we advance the iterator, the counter iterator from within the body of the loop. So as you can see in line 17, we use the find algorithm with the begin as the counter iterator and the end being the end iterator, and we're looking for the new line character. So if we look at the input, basically we'll search from 2 and we'll get back an iterator to the end of this line. So with that information, that is in essence like a string view of each particular line. So we use a special algorithm called from characters, which we are able to start from the count, the starting iterator to the end of the line, this new iterator which we just obtained from the find algorithm, and we put the result into number. So this is similar to the STOI which we used in the stream version, which we can see here. In this particular case, I used unsigned values, so I use a different variant of the same function. So we get the number, so we check if it's greater than 0. This is how we determine whether we are at the end of a section or we're within the normal like within a line within a section, so to speak. So if we get nothing, that means we're at the end of the section. So in that case, we can reset the sum just like we did before. And in this particular case, we reset the counter iterator. So we jump forward, not just by one, but we jump forward like a couple of steps to where the end line is. So when we come back to the loop, this is why we're advancing by 1, because at this particular point at the end of the section, the counter iterator is actually just pointing to the new line. So we want it to go to the next position, which is the beginning of the next line. So that's what's going on there. So this is just scratching the surface of what iterators are. There's a whole lot that can be done with them. It's a newer API, like I said, not held back by the issues of streams. And it's actually like iterators enable us to build far more advanced scenarios. In fact, the range adapters of C++20 are actually based off of specialized iterators. As you can see here, this is a documentation for, the iterators, the iterator page that we've been looking at. So just scrolling down, we see the different things in touching on iterators. We have concepts which are used to, kind of like specify the different behaviors that are available. We have type traits, which enable us to kind of like examine iterators. We have some more concepts, and so there are these adapters. Adapters are actually like the types of iterators that are used in the range adapters. So you can see here there's a ranges library, which is very similar to the algorithm library. In fact, they're almost like what it's a replica, so to speak. But the range adapters gives us the idea of creating views into containers, but those views can be combined and adapted to more complex like make views out of other views, which is mainly just playing around with the iterators. So we were not going to be able to get into that today. Maybe we'll talk about that next time. But I just wanted to say thank you for your time. Thank you for your attention. Thank you for all those who are able to make it to the meetup. Thank you for those who have joined the server. We welcome all who are interested in C++ and learning how to program better to come and join us. We generally have a meetup every month. This particular one was slightly different. We're trying to broaden our horizons. So in this particular case, we did try to make it a bit more interactive. So let us know what you think. Come join us. Thank you for watching. Thank you.